but which is my mom's fiance.
Okay. All right. Let's look at, let's kind of go on here. First of all, do you have any questions about the first two?
No, I got those like solid.
All right. Let's go on to solving and graphing inequalities. Let me open this up so that I can draw some. Do a simple one. How do I graph that?
I have no idea.
Well, you kind of graph it as you would a straight line. In other words, a straight line would be this. Okay?
Okay.
How would you graph that straight line? Where would you start?
Maybe on the like x-axis, go up 3.
Well, you're right in a sense. That is the y-intercept. In other words, here's the standard format. Y equals mx plus b. Okay? Where that is slope and that is y-intercept. So
okay.
In the function we're looking at, the y-intercept is clearly plus 3. That means the function goes through that point, 0, 3. What's the slope of the thing that I drew?
0.
What's the coefficient of x? That's always the slope. That's what m is the slope.
Is it just 1 then?
It's 1, exactly. Which means I go up 1 and over 1. Now I have 2 points. That's all you need for a straight line. So my solution is going to be either a dotted line or a straight line there, because we're dealing with inequalities. Hold on. Don't know what just happened. Alright. So whenever you're dealing with a linear function, which is what this is, it means it's a straight line. It's not a curved line. It's not a circular line. It's always a straight line. Okay?
Okay.
And that's the straight line that we would be looking at if I told you y equals x plus 3. That would be that straight line.
Okay.
Okay? So that's the first thing to recognize about inequalities, is that they really, you graph them as if they were a straight line. Now, is it a solid line or a dotted line? And that depends entirely on whether that is a greater than or a greater than an equal. In this case, is it a dotted or a solid line?
I'm guessing a dotted line?
Yeah, because it's greater than only. Okay? So now, so there's our line. And the inequality says that y is greater than that. So if I had to shade one side of that line or the other, which one would I shade? Above or below?
Above.
Yeah, y is greater. Always look to the y-axis because these things are always going to be in terms of y. So if y is greater, then just find any point you want on the y-axis that's greater than that line. Well, there's a point. That tells us that that's the side you need to shade.
Okay.
So what I've just drawn is this function. Now, let's go a little further. Still haven't learned this program. I guess I got to do it the hard way. Let me give you this problem. Hold on. Lost my cursor somehow. How do I graph that? Where would I start?
I think you would start on the y-axis. Going down one.
Good. You're right. You always start on the y-intercept. Okay? Now,
Okay.
what's the slope of this line?
It's 100.
Is that this kind of slope? Is it this kind of slope? Is it this kind of slope? Is it steep or flat?
Steep, I guess?
Steep, exactly. In other words, that's what that line would look like if it was y equals 100x minus 1. That would be that line. Okay?
Okay.
But it's not. It's y is less than that. So first of all, do I need a solid or a dotted line?
A dotted.
Yeah, when it's less than, it's dotted. When it's less than or equal, it's solid. So that's what we have, which means I'm going to use a dotted line. Now, I'm approximating the slope here. Okay? I'm saying that's a slope of 100, meaning that I go up 100 and over 1. In other words, it's a very steep slope.
Okay.
Now, which side of that do I have to shade?
Below.
Exactly. In other words, the only thing you ever care about is what y is. Everything is in terms of y. So you look to the y-axis only. So it's all I have to do is find a point on the y-axis that's below that line. Well, there's a point that's below that line. And that tells me that this is the side that I'm shading. Okay?
Okay.
Now, let's take a slightly more difficult one. Hold on.
I have a question.
Uh-huh.
I have a question.
Yes, go ahead.
So for the slope, So, like, if you're trying to graph the slope, so you do the, like, y-intercept first.
I'm sorry.
And then,
Listen, hold on. Let me back up. I made a mistake here. That's why you have a question.
okay.
Because I did it wrong. Okay, let me go back. Okay. First of all, there is a point that is below that line. That point right there.
Okay.
And no, I didn't do it wrong. I'm sorry. That does define that area right there. Now, what was your question again?
Well, I think I'm just confused on, I know what the slope is, but I don't necessarily know how to draw the line, like, from the points, you know?
Okay.
So, like the 1 over
Let's
something?
do some more practice on this.
Okay.
Let's say y is greater than or equal to 3x plus 2. First of all, tell me how to graph that.
On the y-axis, go up 2.
So I know the curve or the line goes through that. What next? In order to graph a line, you have to have 2 points. Any other point will do. Any other point. You can come up with another point that fits this equation, connect the 2 points, and there's your graph of the line.
Okay.
How do I figure out a second point?
So, could we do, like, 3, like, up 3 on the y-axis, too?
And over how many?
1
And which way?
to the right.
Yeah. So if I go up 3 units and over 1 unit, there's my slope. So that would be the equation of that line, y equals 3x plus 2. Now, it's not an equation, it's an inequality. So first of all, I have to determine whether that's a dotted line or a solid line. And then I have to determine whether I'm shading above or below the line. First of all, is it dotted or solid?
It's dotted and you shade it above.
Well, it's solid because of that.
Oh, because it's equal to 2.
Yeah,
So.
it's only dotted if it's greater than or less than. That's it. But you're correct that you pick any point above that. In other words, I'm only looking at the y-axis, and that area is that area right there. So that is the area suggested by that inequality. Now, let's do a tougher one. Let's do y is less than 2x plus 1. Now let's we'll make it easier. And then we also have y is greater than 3x minus 2. So I want to find the area that satisfies both of those inequalities. Well, let's start by graphing them. First one, how do I graph it?
On the y-axis, up 1.
Okay.
And then you go up 2 over 1.
over which way? Everybody makes that mistake. They always say over. But you really have to say over in the correct direction. Otherwise, it's not necessarily going to be correct. So do I go up 2 and to the right one or up 2 and to the left one?
To the right.
Yeah, because I want it to be a positive slope. Now, is that going to be a solid line or a dotted line?
A solid line.
Which side of that line do I need to shade?
The left side.
Don't say left or right. Say up or bottom.
Up.
Nope. That's why. It's confusing. In other words, you should only be looking at the y-axis. That's it. We don't care about the x-axis. We only care about the y-axis. So y is less than this line, correct?
Yeah.
That means it's below. So there is what is below that line. And I'm shading it with horizontal lines because I'm going to shade the next one with the vertical lines. And wherever they're the same, that's my solution. Okay? Now, let's look at inequality number 2. Where do I start that?
On the y-axis, go down 2.
What's its slope?
3. So would you still go down 3 from that?
Well, you can do these slopes in a number of ways. You can go, for a positive slope, you can go up 3 and to the right one. You could also go down 3 and to the left one. That'll give you the same line.
Okay.
So it's important to know that. The thing that's key is that you end up with a positive slope, not a negative slope. Do you have any questions at all about what constitutes a positive slope or a negative slope?
Why don't you just go over it?
I will. Let's finish this problem before we do. Okay. So y is greater than 3. A slope of 3 is up 3 and right 1. Okay, so if I connect those 2 points with a straight line, that's what I get. Which side of that am I on?
You would shade
Above or below?
Above.
Always say relative to the y-axis. We don't care what it is to the x-axis. We want to know what it is to the y-axis. And you're right, it's above. So everything above that point, I'm going to shade with a vertical line. And now the solution to that problem is this area right there. It's the area where I have shading both horizontally and vertically.
Okay.
Okay. Now, let me test you on positive and negative slopes. I'm going to draw a line. You tell me what its slope is.
Negative.
Nope. Notice that it goes from lower left to upper right. That is a positive slope. If I were to put a ball there, it would not roll. If a ball does not roll, it's a positive slope. I'll give you another one.
Negative?
Yeah, because if I were to put a ball there, it would roll downhill. So that's a negative slope. Some of them are easy, some of them are hard. What's that?
Positive.
What's that?
Negative.
To go from lower left to upper right?
Oh, wait, so
Positive.
positive?
If I put a ball there, it's not going to roll uphill.
Okay.
So that makes it positive. Balls that do not roll are positive slopes. Balls that roll are negative slopes. In other words, if I change that slope just a little bit to that, and remember, you're always putting the ball on the right side of the line. Is that ball going to roll or not?
Yes, it will, so it'd be negative.
Exactly. How about that one?
It would be positive.
0. Slope
Okay.
of a horizontal line is 0. Now, let's work our way up from that. What's the slope of that line?
Negative.
If you put a ball down there, which way does it roll?
Up. Well, it doesn't roll.
It doesn't roll. It makes it positive. In other words, it's always opposite of whether the ball rolls or not. I hate to use that as an example, but that's the best way I've figured out how to teach this. So that's a slope of 1. Okay, and by that I mean it goes up 1 and to the right 1. Goes up 1 to the right 1. Goes up 1 to the right 1. You with me?
Yeah.
What's that slope? Approximately.
2.
Good. What's that slope?
3.
Believe it or not, that's probably closer to 5.
Oh, because is it on the y-axis?
It's always how much up and how much over it goes. That's it. That's the only thing that matters. Doesn't matter how I draw it or how anything else. It's rise over run. That's slope. So this last one that I drew, what do you suppose that slope might be? Think of how much would I have to go up and over. God, that looks like it could be a slope of 10 or something, right?
Yeah.
Okay, we'll call it 10. It's not important what it is. It's important that you see what's going on here. Now let me steepen it even more, but not yet, so that it's a negative slope. In other words, the last black line that I drew still is a positive slope. If I put a ball right there, it's not going to roll uphill. So it's a positive slope, but what do you figure it might be?
15.
Well, how about 100?
100, okay.
In other words, as I approach a vertical line, my slope approaches infinity. So what's the slope of a vertical line?
Infinity?
Yeah. Now, they don't like to tell you that. They generally tell you that the slope of a vertical line is undefined. And that pretty much means the same thing in Algebra 1 class. You will learn in higher math that they're not exactly the same. But what's important is to know that as this slope becomes steeper and steeper and steeper, it approaches infinity. And if I had a slope that was truly vertical, like a vertical line, then it is infinity. But they don't call it that. They call it undefined. Okay? Now,
Okay.
notice that it's important, so I'm going to keep on this. I'm still going to give you a bunch of slopes, and I want you to tell me what they are. Positive, negative, undefined, or zero. There's our choices. Positive, negative, undefined, or zero, meaning flat. What's
Negative.
this? Yeah, because if I put a ball there, it's going to roll downhill. That makes it negative. Horizontal line.
Zero.
Vertical line.
Undefined.
That's supposed to be a straight line.
Okay. Positive.
And notice one thing. Yes, you're correct. If that were a straight line, it's positive. If it were actually the line that I've drawn, you wouldn't be able to tell. Because the slopes here would be positive, the slopes there would be positive, but then when I get up to there, it actually looks like it turns into a negative slope. So it's very interesting that the slopes of curved lines are completely different than the slopes of straight lines. If I have the slope of a straight line, it's either positive, it's one of these four answers. What's that one?
Positive?
Yeah, because if I put a ball there, remember I always go to the far left side of the line and I put a ball above the line. If it will not roll uphill, then it's positive.
Got it.
I think that's the best way to tell. If it goes from lower left to upper right, it's positive. If it goes from upper left to lower right, then it's negative. If I put a ball on the right side of that line, it's going to roll downhill. That makes it a negative slope. If they put a horizontal line, the ball will not roll at all. It'll stay there. And what's the slope of that? Zero. It's up zero no matter how far over you go. And likewise, if I put a vertical line, it's up an infinite amount divided by zero. So if you use your rise over run, it makes more sense for these horizontal and vertical lines. But very important that you know the slopes on these. Not that you know the numbers, but that you know the direction and whether they're positive or negative.
Okay.
Okay? Phoebe, I will, let's see. Have you and your mom figured out exactly what you want to do? Do you want to schedule something? Do you like these 2 times every week throughout the summer?
I think so, but I'll have to talk to my mom. But I have one question. Well, I kind of want to do some, like, extra stuff for the days that we're not meeting. So do you recommend anything like a book or something to do homework from?
Phoebe, I can give you everything you need in terms of work material if you're looking to do extra stuff.
I
So
would love.
rather than recommend a book, I would say, yeah, you go to Chatfield. So you're going to be taking the SAT, correct? Not the ACT?
I have no idea. I don't know the difference.
Well, it's your college entrance exam, and everybody used to take the ACT, but they've changed the SAT, and Chatfield's kind of changed to where everybody takes the SAT now. So
Okay.
if you want to practice general math, go get a practice SAT book. Now, that's not going to be all that useful to you because that's going to be half geometry and half Algebra 1. But you could certainly work on the Algebra 1 part. You're not
Okay.
going to be able to do the geometry part yet. But there is no more basic math than there is in that practice test. If I was going to teach somebody that had no knowledge of math at all, I would start with the SAT exam.
Okay.
So I can certainly I've got a number of those online. You don't actually need to go out and buy a book. Just go to SAT practice exams
Okay.
online, and they'll show you all kinds of them that you can just kind of go through and get a feel as to whether you really understand it. Ignore the geometry problems, but the algebra problems are, especially the ones at the beginning part of the exam, should be stuff that you can do. Although, in all honesty, this is pretty basic stuff. What happened to it? Until we cover a little bit more here. As all we've done is cover the first paragraph. Once we cover 3, 4, or 5 paragraphs, then you'll have a lot better chance of understanding those questions that you'll run into on the SAT.
Okay.
Okay? This is very, very good stuff. In other words, you need to be able to do each of these bullet points here. You need to be able to, every single one of them. I haven't seen a question yet that isn't absolutely critical for understanding algebra. And I guarantee you that if we can get through these 5 subjects, you will pass your exam and be able to take geometry. And
Cool.
I assume that's your goal.
Yeah.
Well, it's not going to take a lot. I'm a little hesitant to give you an algebra book because a lot of algebra books will get into Algebra 2. You don't need to know Algebra 2 at this point. You only need to know Algebra 1. So the best way to do this is to go through these problems that you're seeing here on your material and make sure you know how to identify a function, how you figure out the domain and range. Now, I will work with you on every single one of these and tell you how to do it in terms of what you can do in the meantime. Here, the best thing, even though you were pretty good on this, and I mean that highly complimentary, the best thing you can do to advance your math skills is this thing right here.
Okay. I still have that.
emathlab.com.
Okay. Yeah, I have that still saved on my computer.
Spend 5 to 10 minutes every night doing these. And
Okay.
I can guarantee you it will make a world of difference. And I'm saying that even though you were pretty good. You were better than most students. I usually don't show this to most students unless I see a problem. And I thought I did originally, but when I went to this and we went through it, you were pretty good on it. So, but you can always get better.
Yeah.
And nothing will help your math more than getting very, very good at this. So, and it doesn't take a lot of time. If you were to spend 5 or 10 minutes a night until you can do 10 problems and get 10 problems right every time, then you're done. If you're doing 10 problems and only getting 9 of them right, you need to keep doing it until you're getting 10 out of 10.
Okay.
That's how important this is. Okay? So I will let you go for now. And your mom, I believe, knows how to do an online session. I think she did both of these online, did she not? Yeah.
Yeah.
Because I would have put your name, and she must have put her name. So she knows how to schedule sessions online. And if you find that there is a particular time of day or day that you want to just do them every week, just let me know and I can lock it in for the whole summer.
Okay.
Otherwise, I will wait for you to schedule another one.
Awesome.
All right, Phoebe, you have a good week.
You too. Thank you so much.
Bye-bye.